In this first chapter, we will be introducing uh, statistics and talking about some of the vocabulary of statistics. This is our um, first lesson, so we'll just kind of do an overview of some things. Section 1 in this chapter is just an overview of statistics, what statistics is, and then as we get into section 2 and 3, we'll talk more about types of data, how to collect data, and how to design experiments so to avoid certain issues. So, our section objectives, we want to define what statistics is. As we start doing some calculations, we need some working vocabulary so that we'll know how to discuss the different topics that we're going to cover. And as I say certain things, then if you know what these definitions are, then it's going to help you have a better working knowledge instead of having to go back and look up, well, what's he even talking about? So the two big topics that we begin with are going to be talking about the difference between the population and a sample and parameters and statistics, and we'll get into the details of those. We also are going to look at how descriptive statistics and inferential statistics, how they're different, what they do, when they're used. So data is some information that comes from observing. Could be just looking out at your environment that you're wanting to study. It could be doing a survey. It could be putting a questionnaire out on Facebook. Could be asking people. It could be doing some research. But data is the information that we collect along trying to study some type of happening. Just list some examples of some information. Trying to get this to go to the next slide. So, in general, statistics is defined as the science of collecting, organizing, analyzing, and interpreting data. We have to collect it. We have to have some information that we're going to study. And once we collect our data, we have to make sure it's in an organized form. We might put it in order from smallest to largest, or we might put it in different categories. But we have to organize our data so it's not just piled up on our desk in a mess. We want it organized in a very easy to evaluate manner. Then we have to run some calculations or put things into a table, do some type of analysis to see what the data has to say, and then we have to interpret it. Well, what does this mean? How does this affect our population, or what does this tell us is going on in that situation, so that we can possibly make some changes to make it better. This is one definition that this book uses here, population, and I've never run across it defined this way. So most books define population a little differently. So when we think traditionally about population is a group that we're going to study. It might be that we want to know how all of the voters in a certain district feel about an issue. So all of the voters would be our population. Or it might be that we have a plot of land and we want to know some characteristics about the timber on that land. All of the trees on that land would be the population. Or if it was a group of animals in a region, Could be that all of the animals there make up our population. Here, this book defines population as the outcomes instead of where those outcomes are retrieved from. Instead of being the people or the animals or the trees, they call the outcomes the population. And the thing that makes this population is that it's all of them. But that's not going to be our working definition. Our working definition is going to be that group that we're pulling from, that we're analyzing, as long as it's the entire group. So as we are tested, that's going to be what we can look at as the population, that entire group that we're studying. Now the sample is a subset of that group. So if we have, like they show here, we have a group, maybe a group of students, could be all of the students in a class, and then we select a few students by some method to study, then this would be our population, and that subgroup would be our sample. So here's an example. In a recent survey, 834 employees in the United States were asked if they thought their jobs were highly stressful. Of those 834 respondents, 517 said yes. Identify the population in the sample and describe the data set. So for us, we're going to consider instead of the responses, we're going to consider all employees to be the population. And then our sample are going to be just the employees in the survey. So it might be that the big group is all employees in the United States. All employees in the United States. And then 837 people were asked a question. So that smaller group will be our sample. So the population is all employees nationwide. The sample is just those people that are a part of our survey. And their definitions are not far from that, but they are just considering the population, the answers instead of the actual people. And we want to consider the people to be the population in the sample. So the data are their answers. The yeses and the nos. 517 people said yes, their job was stressful. 317 people said no, their job was not stressful. So that's what we mean by data. Now, words that we often deal with are parameters. In general, a parameter is any calculation on data that comes from the entire population. If we collect data from the entire population and we run an analysis on it, that analysis, parameter and population both start with a P. But if we collect a sample and we run calculations on just the sample, then that's a statistic. Statistics is what we're studying. So most of what we're going to be doing is calculations on data from a sample. We ask, or we collect a group of 1,000 people and we calculate their average age. That calculation, since it came from not everybody in the whole state or in the whole country, since we just collected a group of people and did a calculation, that calculation is called a statistic. If we were able to get the age of every single person in the entire country and calculate the average age, that would be a parameter. But it probably is evident why we often do statistics instead of parameters is because often populations are so vast, so huge, that it would take forever to do a calculation on the data that comes from an entire population, where we can select a sample that hopefully is representative of the population, and we can do a calculation on it. And if we've done a good job of selecting our sample, the parameter and the are going to be very comparable. They may not always be exact, but we can infer things about our parameter on our population from knowing the statistic. Also, it's not always possible to get the entire population, to measure stuff on the entire population. So sometimes we have to collect samples for that reason. If we're on an assembly line and we want to test the strength of a part, and to do that we're going to destroy the part, we wouldn't want to select the entire population, because then we would destroy everything we made. But if we select every 200 part and we test how durable it is, we've only destroyed a few, but we can infer about the entire population on our assembly line of how strong it is. So there are times that it's not possible to select or to calculate something on the population. Sometimes it's just not advantageous. All right, so here we have an example. Decide whether each number describes a parameter or a statistic. So here's a survey of several hundred collegiate student athletes in the United States found that during the season of their sport, the average time spent on athletics by student athletes is 50 hours per week. So there are several hundred student athletes that were analyzed, but that's not all of them. That was just a subset of our population. A calculation was done based on how much time they spent studying. So since we did a calculation on data from a sample, not from the entire population, then that's why this is a statistic. Now, the second example, the freshman class at a university has an average SAT math score of 514. Notice it says the freshman class, meaning everyone in that freshman class, not just a subset of that freshman class, but every one of them. So here's a calculation done from data that comes from every student in that freshman class. So this would be a parameter if we're considering the population to be the freshman class. Now, if you consider the population to be everyone in the school, then the freshman class is just a subset of that, so this would be a statistic. But if we're only studying the freshman SAT scores, and we have collected the SAT scores of every freshman, then the freshman is our population, so any calculation done on that would be a parameter. All right, in a random check of several hundred retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. So notice it said a random check, several hundred retail stores. Is that every store, or is that just some stores? Well, it's not every store, only a few hundred retail stores were selected. So the stores that are selected make up our sample. And then the Food and Drug Administration determined, were they storing fish at the proper temperature or are they not storing fish at the proper temperature? 34% were not, so that's a calculation from a sample, so that is a statistic. That's a statistic. So we mentioned that we're going to talk about different types of statistics. One type of statistics is descriptive statistics. It involves organizing, summarizing, displaying data. The word here is describe. Descriptive. Describe. We're describing things. Often when we describe things, we use tables. We make some kind of table and put information in it. Or we have some kind of chart. It might be some kind of bar graph or some kind of circle graph. Might be points with a line going through them, lots of different charts we can make. Or it might just be a calculation like an average, a mean, a median, a mode. Lots of different calculations we can do. So these are things that are involved in descriptive statistics. Oops, now I got that writing on top of my other definition. So inferential statistics, we sample data, and from that, we try to draw conclusions. We're trying to make an inference. I spelled that wrong. And of course, I don't have a erasing tool on here, so I can't fix it. So we're just going to say is to infer information about our population. Trying to do three things here at one time, and I misspelled that word. So we're trying to infer something about a population. We're not always necessarily inferring about population. Sometimes just from our data, we're organizing it and we're describing just specifically something about the data we have. But sometimes we're wanting to infer things about a population. When voter polls are taken, they're trying to infer what is going to happen at the election. They don't ask every single voter who they're going to vote for, but they ask a sample of voters, which candidate do you prefer? And they'll say, well, 53% say they favor one voter, 42% favor another voter, and then there's some that are undecided. Now, they didn't ask every single person, but they asked a sample of people, and they're trying to infer what is going to happen at the election. So that's an inferential statistic. So then they give some examples. Here they want us to identify the population in the sample, and then to determine if it's inferential statistics, if it's descriptive statistics. So let's just look at this one. A study of 2,560 U.S. adults found that of adults not using the internet, so we're talking about adults not using the internet, 23% are from households earning less than $30,000 annually. So here's a chart over here. So from adults that don't use the internet, 23% have less than $30,000 available in their household. 12% have basically between 30 and 50,000. 6% between 50 and 75,000, and then 3% have over $75,000 available. So apparently there's other reasons that some adults are not using the internet other than just not having access to it or not being able to afford it. So the population, and we're not going to say responses, but it's the population of all U.S. adults. The sample is 560 people in the United States that were selected and asked this question. So the part of this that is descriptive is when it says 23% of these adults that don't use the internet come from a household that makes less than $30,000 a year. So what is an inference that we can make? So notice there's a description. We've done a calculation that describes the data, but we can also infer something about our population or about what is happening here. So it says a possible inference drawn from the study is that lower income households cannot afford access to the internet, which is a very real issue that we have. Now notice if we add these together, this is, let's see, 35, 41, 44. This only accounts for 44% of the people sampled. So there are other reasons out there why people don't use the internet. It could be that they're not interested in using the internet. It could be that they live in rural areas where they don't have access to the internet because the internet is just not available there. Maybe they don't have time. But for our question, we've described using numbers to describe what our sample says. 23% come from this category. Notice the data does not specifically say why those people do not use the internet, but we can kind of infer what we think or a possible reason for that. It could be that they can't afford access to the internet. That might not be the reason that they're not using it, but that is a possible problem. Here's another one. A study of 300 Wall Street analysts found that the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. So our population is all high-tech earnings forecasts from all the analysts. So all the analysts that were made, all the analysis that were made would be our population. We're specifically looking at 300 of those analytics for this study. So the part of this that represents the descriptive part of statistics is the 44%. That's describing our data. 44% for those who incorrectly forecasted earnings. So this is the descriptive part because this describes. This other part is the inferential part because it infers a possible reason for that. It could be that the stock market is difficult to forecast, even if that's what you do for a living. So that's one thing that can be inferred. Hey, this whole business of determining which stocks are going up, which stocks are going down, that's not just something that's easy to do. It's a difficult task. So that's inference that can be made here. All right, so this is an overview of that first section. Hopefully this will help as you get into looking more into this particular material as we go.